Hello. In this video, I'm going to introduce you to a new function called mod, or MOD. Mod is a tricky function that can be hard to learn, but it can be a very powerful one, particularly when you're dealing with models that have time in them and have things occurring at regular intervals. Something like, every quarter something happens or every other month. And so it's going to give us a lot of power in allowing our models some flexibility in how we build them. All right, so let's start out by just looking at the mod function, and I'll give you an example. So the way mod looks, and we can see the name right here, or the description, it returns the remainder after a number is divided by a divisor. All right, so let's just look at how that works, and then we'll get into the details. So 13 could be our number, and let's divide that by 3. All right, so if we remember back to kind of elementary school and when we were doing division, we would say that 3 goes into 13 4 times with a remainder of 1. Right? 3 times 4 is 12, plus 1 gives us 13. And so mod gives us that remainder. It's what's left over from evenly dividing the number. Right? So if we change that 13 to a 14, now we should have left over 2, a remainder of 2. Let's change that to 15. Well, 3 should divide evenly into 15 5 times, and so the remainder is 0. All right, so how is this going to be useful for us? Well, it allows us to do things periodically based on how often we expect something to happen. For example, let's start out with an example here where we look at interest payments over the course of a year. So I'm going to use my sequence to lay out 360 days. We're going to assume 360 days in the year just for some convenience here. And let's say that they pay interest every 30 days. All right, so let's plug that in up here for our frequency. And we're going to pay interest every 30 days. So in that case, what we can do is we can set up our mod. We can take our number of days, and our divisor, we're going to use 30. We'll lock that, and let's copy that down. We go to the bottom and paste it. And we're going to take a look at what we see. We see the divisor, the remainder gets bigger and bigger as we expect. But then when we hit 30 days, we get a 0. All right? And then we start building up our remainder again. And then at 60 days, we get a 0. So now every 30 days, we're going to get a 0 from this formula. And that allows us to use that as a condition to determine when we should pay interest, for example. So I can change this function now. I'm going to say if our mod is equal to 30, then give me a 1, otherwise give me a 0. So now we're only going to get that 1, or an indicator, if it's the time to pay interest. So let's copy that down, and we should see on day 30, we don't see interest. And I realize I just made a mistake. It wasn't when it equals 30, it's when it equals 0. Right? There's no remainder when it equals 30. So let's make that adjustment. And now we should see when we paste that, we should see at day 30, and also way down at day 360, we should see 1s. And that'll happen every 30 days. So now, when we get to our example, we could think about tracking how interest grows in our account. So let's say we have $1,000 of savings. Our interest payment, well, first we got to figure out our periodic rate. All right, let's assume that the annual rate is 5%. We're going to assume that's an APR. So our periodic rate is going to be that 5% divided by, well, however many periods we have in the year. So we typically have 360 days. So let's divide that by our periodic frequency. And we see that our rate is 0.42%. So our interest payment should be the beginning balance times our interest rate times our indicator variable for whether we pay interest now or not. Notice this is going to work for all of our cells because whenever there's a 0, you're not going to pay any interest. And so we can use that interest payment of 0. Our ending balance is now our beginning plus our interest. And just like with any of our other balance exercises, we link next period's beginning balance equals last period's ending balance. We can copy this formula down. And now we can copy this whole model down to the bottom. And we can track how our balance grows over time. And we should see that our first interest payment happens on day 30. We get paid $4.17 in interest. It adds to our balance, and we continue to grow throughout the year. All right, so what can we see from this? Well, by the end, we have 1,051.16. Let's actually use our max function to just capture that up here at the top. Our max, since the balance is growing, we can use max to get the ending balance. And we see that if we earn interest every 30 days, we end up with $1,051.16. Now, compounding monthly is actually better than doing annually, right? We can set this to annually by changing our frequency back to 360. In that case, our mod function is only going to trigger when the divisor of the number divided by 360 is equal to 0, which only happens once in our data at the very end. So we see that we would have 1050 in interest if we compounded annually. All right. We have 1051.16 if we compound monthly. If we compound bi-monthly, so every 15 days, now we get 1,051.22. If we go every other day, $1,051.26. And now you can see really how the mod function's working, right? It's going 0, 1, 0, 1, 0, 1. So it's modulating back and forth for us at a regular interval. Frequently, we'll want to do something quarterly, so we might set this to 3. And we see every 3 values is a 1. All right, so that'll be useful when we're thinking about quarterly reporting. You can also think about this if you're projecting your own income forward. You might want to, pay certain bills semi-annually, right? You might pay your car insurance twice a year. So in that case, you could set the frequency to 6. But it allows us to really see how periodicity and allows us to control that periodicity within our model. Here we can see that the more often we get paid interest, the more it compounds, and the higher our end of year balance is going to be.